Hello, Bachcho. There are few questions from capacitor. So this is question number one. What this question is, this is a capacitor and it is charged up to a charge Q, or it is not connected by a back. It is isolated capacitor. This is a dielectric slab, and this dielectric slab has a constant K, dielectric constant, thickness is D. Now we want to insert this dielectric slab inside the capacitor, and this dielectric slab is being inserted inside the capacitor with very slow. That means almost it is going with zero velocity. So what they have asked us, find out the force on this slab applied by external agent to do so much, right? So this external agent, how much external force he is going to apply on this slab. Let's see, Bacho, how this external agent will apply the force. When this slab is going to insert inside the capacitor, due to induction, this side of the slab get negative charge because this is positive charge, and this side of the slab will get positive charge, right? So now these plates will do attraction to this slab, okay? Now these plates will attract to the slab and slab will move inside. As these plates is going to apply some force on this slab, so this slab will get some acceleration and it will try to get some velocity. But in our question, this slab is moving with almost zero velocity, so very slowly. So this external agent need to hold it, right, against this electrostatic force. This electrostatic force is pulling the slab inside, and this external agent need to apply force in this direction, right? So we need to find out how much is the force applied by this external agent to move the slab slowly. So that is the question. So okay, Bacho, so we need to find out force applied by the external agent, how much this force is going to apply. So Bacho, this force applied by this external agent is same as force applied by electrostatic force, okay, because both are working in opposite direction. This electrostatic force is pulling inside and this external agent need to apply in this direction force. So both force must have equal magnitude. So my task is to find out here force applied by electrostatic force, right? So electrostatic force, but how we are going to find out here? As the slab move inside this, but the potential energy of the system changes, right? Potential energy of the system changes because capacitance of the system will change. So potential energy of the system will also change. And you know, बच्चों, one electrostatic force जो होता है, it is nothing but electrostatic force or any conservative force is minus du by dx, right? This is for conservative force, right? Electrostatic, and u is the change in potential energy. So I need to find out the change in potential energy with respect to the position. That will give me electrostatic force. So how we are going to solve this question? Suppose at any time this much slab is inside this capacitor, right? And this length of this part is x. So as you know, Bocho, as the slab will move inside, the capacitance of the system will change and potential energy will also change. So what we need to calculate, let us assume this slab move a small distance dx, right? And when this slab move a small distance dx, at that time change in potential energy of the system is du. So you can say that F electrostatic force is equal to minus du by dx. So here my task is I need to find out potential energy as a function of x. Okay. So to find out this potential energy as a function of x, how I solve this? See, suppose this slab is inside, uh, x part is inside of this capacitor. So you get two capacitor. One capacitor is this side. This side is one capacitor. From here, let's call this capacitor is C1, and this side is second capacitor. Let's call it capacitor C. And both the capacitor are in parallel combination. So I just want to find out potential energy of this system at this time. As you know, potential energy is changing with respect to x. So potential energy of this system, I am going to put this U equals to Q square by 2C. Here I will give preference for Q because Q is constant. And C is the total capacitance of this system. So total capacitance of this system, they are in parallel combination. It's going to be C1 plus C2. Okay. So how much is C1? C1 I am calling this part. This capacitance I'm calling C1. Any capacitor epsilon naught A by D. So epsilon naught A is the area of the plate. So this plate area, okay, but this area is coming in this capacitor. So let's assume this width is B and this length, total length is L. This is X, so this length become L minus X. So area of this part become V into L minus X, V into L minus X, divided by D. D is the width between the capacitor plates, the distance between the capacitor plates. So this is D plus capacitance of this part C2, right? C2 is again epsilon naught area. This area is going to be B into this X, right? So B into X by D into K is the capacitance. To simplify this, C1 plus C2, if you calculate this, so this is the value of C1 plus C2. Now you can focus on calculation. So this is a capacitance and this become the potential energy, right? This become the potential energy. Now, as you know, this potential energy is function of x. This potential energy is a function of x. I want to find out the force at this time. So I will differentiate this with respect to f. F equals to this. If you differentiate this, so this term is constant. This term is constant. Only this part is variable. So what I took it power minus 1. Then I differentiated this. So now you can see how differentiation is done. And this much is the force. So, if you see this force, it depending on x. This is a variable force. You just need to know this. This is a variable. This is not a constant force. Okay. And for calculation, you can. I have done the calculation. You can see this calculation. You can do yourself also. There's a calculation. Again, we are going to solve the same question. We need to find out again force applied by this external agent on this slab, right? When this slab is going inside it slowly. Again, find out the force by this man, but this time battery is connected. So we will solve again same problem as it is, but we need to take care this time it is connected by battery to potential will remain constant. So now this time potential energy of the system is going to be U equals to half CV square. And this C I have calculated in the previous problem, C equivalent, when it is at a distance X, right? So this C I have calculated here, bacho. This was the C equivalent, right? And then this is a V square. And again, if you differentiate this F du by dx, this term is constant, 1 by 2 epsilon naught b by d, 1 by 2 epsilon naught b by 2. Differentiation of this is 0 plus this is goes 1 and b square. This is very interesting to know here, bacho. This force is constant. So just remember this, okay? That when it is connected by battery, this force is constant. So, in this scenario, they ask this question: if this slab goes inside this, and no one is holding it, this slab, you release this slab, then find out its time of oscillation. So, what this do, bacho? Once this slab enter from this point, right, up to this point, until the slab come outside, right? sorry, this is point 1, and until the slab become like this, the force act on it in this direction, this much force act on this in this direction, right? Once it goes out, right, again this same attraction force act on this direction. So this plate do oscillation. It does not do SHM because acceleration is constant, because this force is constant. So acceleration during from this point to this point, it is constant. So this is a proper subjective question. You will solve it somewhere, you can get this question, okay? Just try this question. So बच्चों, what is next question? Next question है, this is the setup, initial set. Find out the work done by external agent to move the plate out. So बच्चों, there are two type of the questions related to this problem. In one problem, they ask the force by external agent, and second question, they ask work done by the external agent. So when they talk about the work done in this question, bachcho, so this external agent is pulling this outside, right? And how much work is done by this external agent. So bachcho, in this problem, you need to take care this formula. Energy supplied to the system equals to energy consumed by the system. Energy supplied to the system is nothing but work done by the battery plus work done by the external agent equals to an energy consumed. System is consuming energy to change the potential. Sorry, to change the potential energy, right, Bachu? So here, what you need to do, you just need to find out work done by battery, work done by agent, and change in potential energy of the system. So let us assume, Bachu, this battery is V, and after removing this plate, this is the scenario. Now suppose this capacitance is C naught here when there is no dielectric, and here capacitance is C naught K. Okay, so now we just want to find out how much is change in potential energy first, right? So change in potential energy is final potential energy. So you will say final potential energy is half C naught into this is V square. This is the initial potential energy. Initial potential energy is going to be half C naught K into V square. So change in potential energy is final potential energy half C naught V square minus initial half C naught K V square, right? Now in next problem, I just need to find out work done by the battery. So work done by the battery, you need to see whether current is flowing into the battery or current is flowing out of the battery. So for that, you need to see the charge. Charge on the battery here is CV. So this is C naught KV, right? And charge here is the initial charge. And this is final charge on the capacitor. It is going to be C naught V. So final charge is less than the initial charge. That means charge is going into the battery. Okay. This charge is going into the battery, right? Because final charge is less than the initial charge. So how much is the flow of charge, Bacho, if you see? Flow of charge into the battery. So flow of charge kitna hua, Bacho? This C naught KV minus C naught V. This is flow of charge. So I can take C naught V here common, it becomes K minus 1. That is the flow of charge. Now, work done by the battery is going to be negative. Work done by the battery is going to be negative, and it is minus flow of charge into potential. So it's going to be C naught V square into K minus 1. Now, bacho, you substitute all the values in the formula, you get the work done by external agent. Remember this formula, okay? Or if you are not able to remember this formula also work here. Work done by all the forces equals to change in kinetic energy. This formula also work here. So work done by external forces is work done by battery plus work done by external agent plus work done by electrostatic force equals to change is 0. And you know, work done by battery plus work done by external agent equals to minus change in potential energy. The same, it becomes the same formula. Okay. Now this one second question they ask is, but in the same problem, if you are inserting this inside it, then how much work is done? How much work is done? Okay. So one is this question. Second question is, if you are putting inside this, so how much work is done? So you need to solve again the same way. Work done by the battery plus work done by external agent equals to change in potential energy. Understood? So now you need to see how much battery have work is done. So whether charge is flowing to the capacitor or towards the battery. You need to see that, and work done by external agent, you can change in potential energy again. You can have. Okay. So in this problem, Bacho, there are two kind of problem. In one problem, they ask you about the force. In this scenario, force is variable, right? In this scenario, force is constant. Remember this, force is constant. If possible to memorize this value, it will be good. Then second question, they ask about the work done. How much work is done? For work done, use this formula. Okay. In all the scenario, whatever this kind of the scenario, whether capacitor is connected, whether battery is connected or battery is not. See, if battery is not connected, then problem is very simple. Then if they ask the work done, then in this scenario, work done by external agent is just equals to change in potential energy, nothing else. This time there is no battery. Okay. The scenario is very simple. But so one more question was remaining, spherical capacitance. The spherical capacitor is there and we need to find out its capacitance. So how this is spherical capacitor, Bacho? This inner plate area is R1, inner plate radius is R1, outer plate radius is R2, both are conducting plates. And this battery is connected like this. So on the inner plate, there is a plus Q charge, on the outer plate, there is a minus Q charge. On this plate, this is plus Q charge, right? And this complete. And on this plate, there is a minus Q charge, right? But now they are asking how much is the capacitance of the system. So you know how to find out the capacitance. On one plate, put plus charge, on one plate, plus minus charge. The first step. Second step, find out the electric field between the plates. So when you find out electric field between the plates at any point at here, you need to use the Gauss theorem, right? So when you use the Gauss theorem, electric field at any point at a distance r, from the center is going to be this. E equals to kq by r square, right? Where q is the charge only on the inner plate. This is going to be the electric. Now, second step is we need to find out the potential difference between the two plates. So to find out the potential difference, there are the two formula. If it is variable, the formula is dV equals to minus E dot dr. If it is constant, the formula is dV equals to E dot L. Remember this, right? So here electric field is variable, we will use this formula. Change in potential equals to this. So now, bacho, change in potential, put the value of electric field into dr. dr is changing from R1 to R2, and potential is second plate potential is V2. In first plate potential is V1, so V2 minus V1 is nothing but change in potential, right? If you see left hand side, I just need to see the modulus of change in potential, okay? Because I just want modulus of change in potential. So change in potential equals to, but you substitute all the values, you will get kq by r square, kq, this integration minus 1 by r and r1 by r2. Sorry, r1, r2, you put all the values, it becomes this. Now, as I told you, bacho, I just want modulus of it. Actually, this value is coming negative. Of course, it should be negative because V2 is at lower potential. But I just want change in potential. So change in potential, I will just make it positive modulus of this, right? And now, this is change in potential KQ, 1 by R1 minus 1 by R2. Please simplify this. Compare this by the equation Q equal to C delta V. So this is the capacitance of a spherical capacitor. Okay, remember this formula. Virtual spherical capacitor, actually you get the three kind of scenario. There is one question. You have this four scenario, 1, 2, 3, 4. They're asking the question is in different situation, what is going to be the capacity? If inner plate area is radius is A, outer plate's radius is B. So here, this is an isolated conductor and it has a radius B. So capacitance is going to be C equals to 4 pi epsilon naught R. R is going to be the B. Right? In the next question, the second part is virtual. In the second part, this two plates is connected by a conducting wire. As you know, when you connect the plate by conducting wire, charge goes to the outer surface. So there no charge is going to be the inner surface, right? Or inner sphere. The total charge is going to be on the outer sphere, right? So field is going to come out only from outer sphere to infinite. So capacitance of this capacitor is going to be 4 pi epsilon naught B. Okay, because the electric field is going to be from here to infinite. The next question is, Bacho, this is third type of the problem. In this third type of the problem, Bacho, what they are telling, to the inner plate you have given Q charge and to the outer plate you have given minus Q charge. But so when you redistribute this charge, I have done redistribution electrostatic. In this scenario, when outer plate is grounded, all the charge here is going to come, plus charge is going to come on the inner plate, okay, and on this surface. And but your minus charge, this redistribution you have done, you can recheck it by yourself. And minus charge is going to come here. Okay, bacho? Minus charge is going to come on here. So electric field is going to establish between these two plates only. Okay. So these two plates, when electric field is only between these two plates, so this capacitance is how much, but you have just done the proof of it. And this capacitance होता है 4 pi epsilon naught. आगे क्या आता है बच्चों? AB divided by, this is AB divided by B minus A, right? When capacitor energy is confined to this region. Next problem क्या है बच्चों? It's very interesting problem. Next problem में क्या है? I have done grounding to the inner conductance. Now on this I have given plus charge Q, on this I have given minus charge Q. But so if you do redistribution for this charges, so on the inner surface it charge is plus Q. Okay, but listen it carefully, that's very interesting, right? Charge here will come minus Q. And 1 plus Q charge will come on this surface. I think बच्चों I didn't कुछ mistake किया है मैंने. Let me recall it. Let me do it. तो हमारे पास एक inner sphere है, conducting sphere. One is the outer conducting sphere, right? And this is the setup. Now we want to form the capacitor. So in this scenario, we want to form the capacitor and we want to put some charge. So on this plate, suppose you have put plus Q charge. Okay. And the outer plate is actually neutral. So now minus charge will come here. And as the outer plate is neutral, so outer plate is not connected to anything. So some plus Q charge will come on outer surface. So here is going to be two capacitor. See, one energy is confined between these two plates. Okay, and one electric field is going to come out from the outer surface to the infinite. Okay, so one is going to come from outer surface to infinite. So they are going to the two capacitor. One is this capacitor, and one is the outside capacitor. Suppose this capacitor is C1 and outside capacitor is C2. So these two capacitor is going to be in parallel combination. How is going to be in parallel combination, bachcho? Suppose this surface has a potential V and this inner surface is grounded. Potential difference between this and this is going to be 0 minus B. So it's going to be B, right? Now potential of this surface is B, and बच्चों this जो ये वाला sphere है ना, outer sphere जो इसका electric field infinite तक जा. So you will assume this, that one plate is this outer and one plate is capped on infinite, and on infinite potential is again 0. So capacitance between this plate outer side and infinite is also V, right? So if this capacitance, this is C, and this plate with infinite is C2, there's parallel combination. So it's going to be C equals to C1 plus C2. And C1 is going to be how much, bacho? It's going to be between these two plates, which is going to be again 4 pi epsilon naught AB divided by B minus A. And C2 is from the outer surface of this to the infinite. So it is going to be, bacho, 4 pi epsilon naught B. So you can treat the outer surface here, na? Outer surface, bacho, B. So this is the, you can treat it is forming isolated capacitor like, okay? सिर्फ बाहर का interaction up to infinite से जा रहा है. So C1 plus C2, it's going to be the capacitance of